7A, finding relevant information. Now, you may notice that we're doing this a little different today, and that's because we're going to be dealing with word problems. Now, I know for some of you that sent a shiver down your spine. That's okay. Word problems are unfortunately life. Pretty much everything you do and deal with in life is a word problem. People don't just give you an easy question and say, hey, add 4 plus 7 for me. They ask you a question and you have to realize that you need to add 4 plus 7. So we're going to start with finding relative information. Now, for me, one of my favorite methods is what are called Polya's 4 steps. Polya was a math instructor. He was very congenial, shall we say. People really liked him. And he realized that people had a problem solving problems. They didn't know how to approach it. Now, his 4 steps relate to any problem. They do not just relate to mathematical problems or scientific problems. If you follow the process, these simple 4 steps, then it will help you to solve any sort of problem that you're dealing with. His first step was to understand the problem. Okay, look at the problem, realize what information you have, what's being given to you, and what you are trying to accomplish in the end. Second step is to then come up with a plan, devise a plan for solving that problem. You have to have a method. Just don't go at it wild and try anything. Come up with a plan, determine how you're going to solve that problem. Third step is to implement that plan. Once you've got a plan in place, move forward with it and give it a shot. And then the fourth step, I modified it a little bit. I call it common sense. The fourth part of solving the problem is to look back and say, is this a reasonable answer to the problem? And does it make sense? Does it answer the problem or solve the problem? And this is, for me, the most critical step of dealing with word problems and solving problems. Many times we go in and we do it and we try something and we get an answer and go, okay, I've got an answer. But if we were to take the time to look back and say, does that answer make sense? Is it reasonable? We might realize, gee, I didn't even answer the right problem. So let's go through an example of this. Here's a word problem. Andy has $10 and wants to buy some lunch. He goes to Da Burger Place and orders a burger for $3.29, some fries for $2.89, and a soda for $1.99. How much money does Andy have left? Okay, so let's go through this process using Polya's 4 steps. So there we go. So I just shrunk that over off to the side. He still has $10. He wants to buy some lunch. He goes to the burger place and orders a burger for $3.29, some fries for $2.89, and a soda for $1.99. How much money does Andy have left? So we want to first understand the problem. So what do we see here? Let's pull information out of it. Andy has $10 and wants to buy some lunch. Okay, so he starts with $10. He goes to Da Burger Place and orders a burger for $3.29, some fries for $2.89, and a soda for $1.99. So he's starting with $10 and then he's taking away $3.29, $2.89, and $1.99. How much money does Andy have left? So we're looking to find the result of this problem. Starting with a certain amount, taking away certain amounts, find out what's left. What is the result? So now we devise a plan. Well, how are we going to do this? Well, one way is we can add up the prices. We know that he's going to spend $3.29, $2.89, and $1.89. So add them all up and we know how much he spent overall. And then we can subtract that total from $10. So there's our plan. So now we implement the plan. So 329 plus 289 plus $1.99 is $8.17. So we've added up the prices. Now we're going to subtract that total from $10. So 10 minus $8.17 is $1.83. So we say he's got $1.83 left. So here comes the common sense part of it. He started with $10 and he has $1.83 left. Well, he started with a certain amount of money. He bought these items and he ended up with $1.83 left. That makes sense. It's a reasonable result because we see that the amount that he spent was less than $10, but it was pretty close to it. So for him to have $1.83 left makes sense. Whereas if you looked at this and you came up with a plan and you implemented that plan and you came out with him having $8.17 left, you added up the prices, but you didn't subtract from 10. Would that make sense that Andy started with $10 and was able to buy all that lunch at those prices and still have $8.17 left? No, that doesn't make sense. Or if you added everything up, including the 10, and came out with him having $18.17, would that make sense that he started with 10, he bought food, and then he now has $18.17 more money than what he started with? No, it does not. So the common sense, did it answer the question? We want to know how much he had left. Yes, it did. And does the answer fit the question? And yes, it does. Well, let's try another one. Zoe has 22 candy bars. She must be a candy machine. She has decided to split them evenly between her 4 children. Her husband will eat whatever is left over. How many candy bars does her husband get? Okay, so Zoe has 22 candy bars. She has decided to split them evenly between her 4 children. Her husband will eat whatever is left over. How many candy bars does her husband get? So shrink that down so we can work on it. First thing, understand the problem. Okay, Zoe has 22 candy bars, so she starts with 22 candy bars. She has decided to split them evenly between her 4 children. So they're shared between 4 people. Her husband will eat whatever's left over. How many candy bars does her husband get? So basically, he gets whatever's left over. So what's left over? That's what we're looking for. How many candy bars are left after she shared the candy bars between 4 people? So devise a plan. Well, we're going to share 22 candy bars between 4 people. So aren't we dividing up those 22 candy bars evenly between 4 people? So we divide by 4. And then her husband gets what's left over. So the remaining candy bars, find the remainder, will be what goes to her husband. So we're going to divide 22 by 4, and then we're going to find the remainder. So now we implement the plan. 22 divided by 4 is equal to 5 with a remainder of 2. So if each of her children gets 5 candy bars and there are 2 remaining, then her husband gets 2 candy bars. Final thing, common sense. Does it make sense that her husband gets 2 candy bars if this works out? Well, one way we can look at that is just go, well, let's reverse the process. 4 people each got 5 candy bars and he got 2 candy bars. 4 times 5 is 20 plus 2 is 22. That's how many she started with. Another way we could look at it is to compare the remainder to how many people there were. So there's 2 candy bars left over. There were 4 people that were sharing out the candy bars. So 2 is not enough to give each of them another candy bar. So it makes sense. The result makes sense. And that's how we deal with word problems. We want to look at it and start by just understanding the problem. What information do we have? What is our end goal? What are we looking for? Then come up with our plan of solving it. How are we going to determine the answer? What's our method? Then put that plan into practice. Implement the plan. Whatever we determine we're going to do, let's try it. Get a result. And then the last step, that common sense, look at it and says, does it make sense? Does that answer the question that's being asked? And does the result fit the question and make sense according to the question? So that's dealing with word problems.